here's what we're going to do today. Today, we're going to talk about angle relationships in triangles. Our EQ, what are some theorems about the measures of angles in triangles? Pretty simple lesson, actually. Find the measures of interior and exterior angles of triangles and apply theorems about the interior and exterior angles of triangles. Key terms: auxiliary line, corollary, interior angle, exterior angle, remote interior angle. Sounds fun? All right, first up, we have what you already know because we already taught it to you. The triangle sum theorem. You don't have to write it down. You already know it. The sum of the angle measures of a triangle is how many degrees? 180 degrees. Okay? Three angle measures of a triangle always have a sum of 180. Any questions on that? Does anybody need to write that down?
Yeah.
You speak now and forever hold your peace. Peace indeed. All right? All right. An auxiliary line might be worth writing down. Auxiliary line is a line that is added to a figure to aid in a proof. Okay? Alright, so if I have, like they took a triangle, okay, and I have a regular old triangle, A, B, and C, one of the things that may help me out when I am going through some of these theorems is add a line at the top or at one of the vertex of the triangles, okay, and that line will help me see some of these other theorems. For example, that line would help me see the remote interior angle theorem, which is something that we're going to go over today. All right, that line would help me see, hopefully, that 4, 2, and 5 are supplementary. Yeah, right? Okay. If the auxiliary line is parallel with the other side of this triangle, which it is in this case, okay, it would help me see what kind of angles. What is 1 and 4? What would they be? Don't know? But did you do last night somewhere? Nope.
Hey, that was terrible.
Okay. Hey, 1 and 4 are called alternate interior angles. How about that? Right? Compared to these two parallel lines, yeah.
Oh, okay.
1 and 4 are alternate interior angles, and so on and so forth. That's why auxiliary lines are important.
Put like this stuff on their hair, it makes it grow.
Bosley,
Miracle.
seen it every day.
Actually, if they don't want that.
Cheer, Pat. All right, hey, check it out. It says, what is the measure? Use the diagram. Y'all probably can't see it. Use the diagram to find the measure of angle MJK. MJK. First off, where the heck is MJK?
There's the M's right there, the J's right there.
Yeah, MJK is MJK. It's that one right there. All right, so here's what we can conclude. If this angle, which y'all probably can't see this, angle K right here is congruent to angle M in that triangle. Let's first off talk about if I've got 88 and 48 as two angle measurements, how do I find the third angle?
Subtract 88 from 48.
No.
Subtract what's the number?
Subtract all the numbers from a buck 80. 188 minus 88 and 48 is how many? Booth, you got a calculator. I told you everything to do. The last human element is typing that into the calculator.
44.
44. All right. Now, watch this, guys. What do the little ring things mean?
That means they're similar.
No,
44.
Means they're, say the C word.
Congruent.
Okay, that means that they are congruent. So now, if I ask, what's that angle measurement? Y'all probably still can't see it. I got 104 and 44 as angle measurements. Take 180, subtract out 104 and 44. 28.
I got 34. What's that? 34.
32. Come on.
I was thinking that, I was like, I did it in my head.
Make me look bad. 32.
What's that? 74.
It's for another question. I didn't ask that question. Okay. So what we could do here is we could take all three of those angle measurements, subtract from 180, and we find all of them.
Oh, I thought the 70 was for him.
All right. Y'all see how easy that can be? Hopefully so.
Oh,
10, 39, 10. A corollary is a theorem whose proof follows directly,
Should we write that down?
yeah, follows directly from another theorem. Two corollaries to the triangle sum theorem, both of which you need to write down. The corollary and, you don't have to write, you just need to write the corollaries, okay? The acute angles of a right triangle are complementary. Oh, complementary. Oh, yeah.
180.
What?
90.
How long does a complimentary breakfast last?
90.
90 minutes. That's the worst.
Unless you're in
example.
Florida and it's
What
like,
is
what?
that?
What's the
Don't worry about it. If you weren't here that day, you were spared. Alright? Now, complementary means they add up to be 90 degrees, okay? The measure, and then the other one says the measure of each angle of an equiangular triangle is 60 degrees. Bonus points to the kid that tells me why it's 60.
What? Because
I wasn't even listening. There are two angles that equal.
Wait, what was the question?
Yeah, you got
So
strong.
you say it's 90?
Because all three angles,
Go ahead.
60 times 3 is 180, so they're all equal.
So-
all equal 60.
They all are equal, 180 in each. 180 divided by 3 is 60. They gotta be equal, okay? That's why we get that.
Where's my phone?
Hey,
You see
Hey,
that?
you haven't seen that many times?
no.
What kind of?
Yeah, I do. You gave me a biscuit.
Almost
Do we write that whole system?
No, you just write corollary and these particular, definitions. Alright, why would this one be true? Why are the acute angles of a right triangle always complementary? You got it,
Okay, so, because you automatically have a
I was like,
90
what are you
degree,
doing?
alright, and hey, she said it right, she said it real fast though. You automatically have a 90 degrees, correct? It's a right triangle. Every right triangle has a right
A
angle.
right angle.
So, keep going, Ms. Shepherd.
so then your left is 90 and you have two angles, so then it's 90.
You got two angles that have to have a sum of 90. By definition, they are complementary. Okay? That's why we can write these particular corollaries. I'll come back. I will come back. Alright, let's get this real quick. Guys, I hope, you don't have to write this down, because I hope it's like crazy easy. But if it's not crazy easy because somebody misses the question when I ask him what it is, then you will have to write it down. Mr. Myrick, name for me the interior angles of this triangle.
3, 2, 1.
Perfect. Name for me the exterior angles. What's the 4?
I
Alright,
get it.
well, I'll be here next. An interior angle. Hey, an interior angle, don't have to write this down either, because this one's pretty easy too. An interior angle is formed by two sides of a triangle. An exterior angle is formed by one side of the triangle and an extension of the adjacent side.
Wait, so angle 3 isn't interior? Oh, I thought it said isn't.
Alright guys, there's no difference in those two slides. The only thing that's different is the fact that we said one of them was interior, all the points inside, then I said added the word angles. It should not make a difference, right? Interior angles are still where?
Inside.
Inside. Exterior angles are still where? Didn't change, alright? Nothing changed about it. Keep it simple. Yes, ma'am.
Will there be an exterior angle?
What would be the exterior angle here?
I mean, no, I know what the exterior angle is. That's on one, but there be.
Yeah, so, okay, so if I wanted to, I could say, hey, this is 5, and that's 6.
Hey, I got someone at the door.
Something
Who's
like
at the door?
Got me?
I think, anyway. Open that door.
Alright, you do need to write this down, okay? Alright, write the whole slide down as a matter of fact. Each exterior angle has two remote interior angles.
Wait, what?
Each exterior angle has two remote interior angles. What is that? A remote interior angle is adjacent to and a remote interior angle is an interior angle that is not adjacent to the exterior angle. What does adjacent mean?
Next to.
Next to, okay? So the remote interior angles are far away from the exterior angles. I'm going to add a little bit to this drawing, what Ms. Shepherd just pointed out. I'm going to add angle 5 right here, and I'm going to add angle 6 right here, okay? I want you to add that to your drawings. I want y'all to draw the whole thing. We're going to make a chart real quick. You need to add this chart to it because it's going to make things easier. Okay, we're going to have angle 4, angle 5, and angle 6. And we're going to go like this. And we're going to put our remote interior angles. Okay, we're going to fill in that chart. That's what I'm going to help you out with. Watch how I do this. You need to pay attention because this might be the hardest thing we do all day. No lie, this might be the hardest thing you do all day, so we'll make sure we get it. Let's use our definition. Remote interior angle is an interior angle that is not adjacent to the exterior angle. We said adjacent means next to, correct? So the way to think about this is start with an exterior angle, 4, 5, or 6, find the angle that's next to it, and pick the other two angles, and you've got your remote interior angle.
Wait, both?
Yeah, there's two remote interior angles, right?
Why would you pick both if it's
Because the angle that's right next to it is 3, so that means that the other two angles are both remote interior angles, and that's why we're going to do this, okay? Angle 4, what angle's next to it?
3.
So what are the other two angles?
1 and 2.
So angle 1 and angle 2.
So 5 would be 2 and 3.
4.
6 would be 1 and 3.
Go through one at a time. What's next to 5?
1,
What are the other two
2
angles?
and 3.
Oh, that's easy.
You're right, it is.
Why'd you say so? Oh, you missed more.
Alec.
It's Alec, and it's not as easy as you think because the sum of these two equals out.
So that's 1 and 3.
6, what's next to it?
2,
2. What are the other two?
1 and 3.
Angle 1 and angle 3. Okay?
3 plus 1 equals 6.
Write this chart down. Alright, here we go. Here's what's up. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay? You probably should write down the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles.
what? It looks like you're kind of like setting it up like solid bricks.
You are. You will be. So like, here's one way to look at it. Angle 4 is x. It's undefined, right? Angle 1 is 60 degrees. Angle 2 is, let's go 45.
So it'd be 45 plus 60 equals
What?
X.
Yeah, that's it. It'd be 45 plus 60 equals x.
What about
But
the
the
third
angles
one?
will-
105.
Say what?
So the angles will be different.
Yeah, the angle, or they could be like this, x plus 3, 2x plus 9. Do the same thing. Okay? Alright? Go ahead and write, I mean, if you want to write the third angle theorem, do it. If not, it's kind of common sense. If two angles of one triangle are congruent to two angles of another triangle, then the third pairs of angles are congruent. Right?
Can they all be true?
Yeah, we would call them congruent. Well, that won't prove congruent triangles, but it'll prove that all the angles are congruent. Okay?
There's
What?
every.
Okay? So, if you don't mind, write those two things down. We'll move on, and that might be it. I might just search in your password after that.
Can you erase them?
Alright, real quick. How would I set this up? The measure of one of the acute angles in a right triangle is 63.7. If it's a right triangle, it has to have a what kind of angle in it? 90 degree, right? and the other two angles have to be complementary.
Complementary.
So to solve this, I just go 90 minus 63.7. Or if you want to, you could go 180 minus 90 minus 63.7. Either one works. 26. Yeah, 26.3. Okay? Simple as pie. Find the measure of angle ACD. So now I'm trying to find ACD. And now I'm trying to find this outside angle, correct? Okay? Angle C or angle ACD is right there. What are the remote interior angles?
2Z plus
A and B, correct? Which are
2Z plus 1 is
2Z plus 1 and what? And what do I do with those two? I add them together and set them equal to the exterior angle. See it? So Mr. Harris, 16 minus 9, you were asking, this is what your problems will look like, okay? Got me?
Yeah.
It's not, guys, you gotta be able to solve multi-step equations. Past math. I don't know what to tell you at this point, alright? That part shouldn't be hard for y'all. Setting it up is the tougher part, right? You gotta remember that you take the sum of the remote interior angles. Okay? You see what it might look like now? Start with your exterior angle. This inside angle's next to it, so don't use that one. Use the sum of the other two angles. Okay? Any questions on that?
No.
This one gets real. If I got two triangles here, IJG and FKH, I got two pairs of congruent angles, which means what's true about K and J? They're congruent. So take 4y squared, set it equal to 6y squared minus 40, which would involve a quadratic, which I am not going to do it. Okay?